All right, all right. Now, this seems awful weird that you are either in the room next door to me or across the hall. For those of you at home, this hasn't changed a whole lot because you have to listen to me in videos all the time. But it's really weird when I can stare across the hall and see people in Mrs. Klein's class, yet you're still sitting here listening to me teach. But that's what happens when we have benchmarks and we still need to review. Now, there's one thing that I'm going to go over. I'm just going to kind of give you a brief introduction to this. We're still going to cover this, I think, a little bit more in class to make sure that we all really get it. But I can see these showing up on the benchmark, and I would rather you have a little bit of schema than no schema at all. So as we dive in, we realize that the title of this Nearpod slide is Weather, Weather Maps, Jet Stream, Gulf Stream, Hurricanes, and Tornadoes. Although I don't remember seeing tornadoes on here at all. Maybe I never added them. And you're identifying weather phenomena, such as the jet stream and the Gulf Stream today, and how it impacts weather not only locally in one area, but globally. So we need to talk about the jet stream. The jet stream has often been described as a river of wind. Now, this river of wind, this is a very wide river, okay? Like you're talking like the Mississippi or something where you could be standing on one side and you really couldn't see the other side very well because it's several thousand miles wide. It's several thousand miles long. The thing about this river of wind is it's not very deep in comparison to how long and how wide it is. And now if we look at this picture down here, you'd be like, Mr. Bullens, I've seen warm air masses before, and I've seen cold air masses. This seems very normal to what we've been studying, and it is. So the jet stream's not going to be overly difficult for you. The jet stream is separated, or it actually separates two different air masses of extreme different temperatures. And because of these different temperatures that you have the cold air up here and you have the warm air down here. Because of that, it causes a difference in air pressure. And we know that when you have differences in air pressure, such as high pressure and low pressure, you're going to end up with wind, which is what the jet stream is a river of wind. So we know that the jet stream is formed because it goes in between a giant cold air mass, which makes sense up north. The further north we go, the colder it gets. And then look down south. Here's Florida and Texas, where we typically think of it as being warm. Gulf of Mexico right in here. And that's going to be a generally warmer air mass. And because it's separating these two, you're going to have this thing right here, the jet stream, which is a river of wind. Now, jet streams, they affect weather around the entire world. These winds can be very, very strong, and they can very quickly push weather systems from one area to another. Now, we've seen something similar to this before with our prevailing westerlies, went from the west coast and moved across weather to the east coast. Well, now you see this other giant river of wind that could also deflect some of those weather patterns that are being moved, or if it gets caught in here, moving them very quickly across the United States. And that's typically because these strong winds have the force to move these weather systems from one place to another. You'll notice it says here, I believe, meteorologists often they track the jet stream and the shape of the jet stream to tell us a little bit about what the weather is going to be like, because again, the jet stream affects weather worldwide, and it also affects it locally. And again, what's going to have the biggest effect on how fast the jet stream is moving? And it's going to be the differences in these air pressures and air temperatures. If it's extremely cold here and it's warm here, like it would be in the wintertime, you're going to have faster winds than you would where this is just cool and then this is hot. It wouldn't be as drastic, and your high pressure is coming down from that cold air that's going to be pushing down. They do shift throughout the year. Honestly, I'd say they move daily. Jet streams pretty much are moving all the time. They snake around. They're always in a different position. In colder weather, they typically move a little bit more south. And so let's take a look at that. So it's not a shock to us. This is not new news to any of us that up north we have these colder air masses, and we learned that because the further away that we get from the equator, the cooler it gets. And we're not shocked that in the southern part of the United States that we have warmer weather. And because there's like this separation of these two, you have this, whoa, that's not what I wanted to do. This jet stream that kind of moves and flows across the United States. Now, in the wintertime, this jet stream very often gets pushed down a little lower. Now, let's think about this, right? Here is North Carolina. Okay? We know that to the north of the jet stream, we have all of this cooler air that we talked about, right? Oh my goodness, Mr. Bullens, get your colors right. There we go. All this cooler air. So in the wintertime, if the jet stream dips below North Carolina, it pulls in all of this cooler air from up north, and we might have a day where it's going to be a little bit colder. There are times when the jet stream is pushed very, very far south, where you might even see the jet stream, let's see, clear annotations, you might even see the jet stream dip so far down as it goes down below Florida. Well, what's going to happen then is it's bringing not only the cooler air in, it starts to do that thing that we hear about on the news about that polar vortex, which is going to start bringing down that extremely cold air. So if you are above, if you are to the north of the jet stream, it's going to be a little bit cooler. There's obviously a difference to that. If you happen to be, say like this, well, your cooler air is going to be up here. And I don't think that shocks anybody that it's cooler in Canada, but maybe in the summertime, some of this warm air from down in the Gulf, all of a sudden we get warmer, more humid air in the summertime because it's pushed up a little farther north. So the jet stream can have a great impact on the types of air masses that are being pulled into a different area. So again, in warmer weather, in the summertime, they get pushed up north, very similar to what we had here. So this would be summertime. We saw what would happen if the jet stream were to get pulled down south, which is what happens in the wintertime. The jet stream moves a little further down. And what happens, especially to us, is it starts to bring us a little bit colder weather. So we do need to understand that if we are above to the north of the jet stream, we're going to have colder air. If we are to the south of the jet stream, we're going to have warmer air. And again, that can affect what happens if we have a cold front moving in or have a warm front moving in, and what other types of air masses it might be bumping into at that time. And the jet stream can deflect some weather. If weather happened to be moving across the United States, it's not just going to go straight through this giant river of wind. It's probably going to push that weather down a little bit. And looking at this one, it could even go down all the way down to Lake Florida and even miss North Carolina, where typically if the jet stream were just in a more of a straight line, it might just go straight across the United States and hit us. So the jet stream is very, very important in the way that it affects weather in different areas. Again, the prevailing westerlies generally are pulling weather across the United States. However, the jet stream can move and affect that as well. The prevailing westerlies move weather, but again, if it hits anything right here, it's not just going to go straight through it. The jet stream is going to deflect it and move it down. We also have to remember, and I've said this more than once, so if I'm saying this over and over and over again, these are the kind of things that pop up on those test questions that we have. The jet stream separates two massively different areas of air temperature, two different air masses, so cold and warm air masses. In the winter, when this air mass happens to be a little bit colder, we happen to have faster winds in the jet stream. If the jet stream, we said this when we were looking at our map, if the jet stream dips down below North Carolina, it brings cold Arctic air with it. And we understand that. That makes a lot of sense to us. However, I want to look at this picture. Boy, oh boy, the jet stream sure does seem to be in a very odd place compared to what we've normally seen the jet stream in here, and this is probably during the winter. This jet stream is moved up way to the north, and honestly, it's a lot straighter. I guess it's still curved, but it's not as snaky as it was in the other picture. This is going to be something that you might see in the summertime. Like here we are at the Great Lakes in like Chicago area where it's not typically hot, and all of a sudden they're getting warmer air that's being pulled up because the jet stream is so high, and they're getting warmer temperatures than normal. So if you are to the south of the jet stream, you're going to have the ability to interact with that warmer air more often. And if it's getting pulled from down here, we learned that that is going to be your maritime tropic. If it's down here over the water, maritime, it's warm, it's tropic, maritime tropic air, and then that in the summertime can bring a lot of humidity, which can lead to some of those thunderstorms that we see during the summertime. We know that the air in the jet stream moves fast, between 100 and 200 miles an hour. Obviously, you're going to watch a video here later and learn that it can move even faster than that. It moves the fastest in the winter, again, because the air is colder and you have the ability to have a greater differences in the two different temperatures, so it's going to move faster. And you'd have higher wind speeds if you were in the jet stream then. Once you leave this page, it's really time for you to kind of like stop this video, pause, and go into the Nearpod and watch the videos about the jet stream and take a few more notes. Once you have finished that, you can come back to this video and click unpause, and we are going to move on to the Gulf Stream. All right, welcome back to my video. Hopefully you had enjoyed watching those videos about the jet stream. So we're going to go from a river of wind and air, and we're going to talk about something called the Gulf Stream. And the Gulf Stream actually has to do with something in the water. This is not a hot band of air that's moving. This is a very, very warm current of water. Now, this Gulf Stream starts in the Gulf of Mexico. You can see that right down here and over in this area right here, which I guess I could draw and put maybe red in there for us, because this is typically warmer water. Why? Well, we're getting closer and closer to the equator the further south that we go, and this water is typically warm most of the time. Now, this Gulf Stream moves up around Florida, up past the coast of North Carolina, along the East Coast, and then it starts to move out and towards Europe. It's very important to understand that this is a very, very, very warm current of water. And what it does is, especially here in Florida, it is one of the reasons why they have warmer temperatures year-round, warmer in the winter, because they have this Gulf Stream and it affects the local weather. It doesn't allow it to get as cold in those areas, and also that has something to do with how close they are to the equator. It causes any area that it's near, especially Florida, to have an increase in temperature. So Mr. Bullens, I see that it goes by North Carolina. Does it raise the temperatures in North Carolina? It does cause us to have a little bit milder winters, and it does help us to have some of those hotter times in the summer as well, because the Gulf Stream affects the areas that it is near. It keeps Florida, North Carolina coast warmer. It actually affects England too. If it weren't for the Gulf Stream, England would be a lot colder than it is. Okay, so let's look here, right? If we look, this is England. If we look, like, if we're talking latitude, England should be like extremely cold, like upper northern Canada, but it's not typically that cold. And that has a lot to do with the fact that the Gulf Stream helps keep that area warmer. Pretty amazing fact about the Gulf Stream. Here's some videos for you about the Gulf Stream. The Gulf Stream changes weather along the coast of North Carolina. We've said that more than once. Again, make sure you watch this video on the Gulf Stream, and it's that time for you to smash that like button and subscribe. Click the notification bell, and we will see you later.